unmistakable high-pitched scream and the blistering speed you feel are the true signatures of a modern supercar. The Lamborghini Aventador serves as a benchmark for this performance, anchored by the mechanical systems sitting right behind the driver. Internal combustion itself is a violent process. Those continuous blasts create intense physical vibrations. The machine has to constantly fight against its own inertial forces just to remain smooth. While you might expect 12 cylinders to create twice the vibration, the V12 is celebrated for the opposite. It provides linear power and a distinct lack of mechanical harshness. The V12 is an elegant mathematical solution to this problem, using its specific geometry to neutralize the chaotic forces of combustion. To see how it works, we have to look at this 4-stroke cycle. Every cylinder pulls in air and fuel, compresses the mixture, ignites it to create power, and then pushes the exhaust out. Because power is only generated in one of these 4 steps, smaller engines have gaps in their delivery. There is actual dead time between each ignition. A V12 uses 12 individual cylinders arranged into 2 distinct banks of 6. These 2 banks are traditionally angled at 60 degrees from one another to form the rigid V shape of the engine block. This chart shows how the V12 architecture fills those gaps. Because the cycle fires 12 times in rapid sequence, a new cylinder begins its power stroke before the previous one finishes. This overlap transforms a sequence of individual explosions into a constant surge of forward momentum. The 60-degree geometry also allows the opposing forces of the firing cylinders to naturally cancel out physical vibrations. This inherent balance means the V12 doesn't require the heavy, space-consuming balance shafts that smaller engines use to simulate smoothness. By spreading the workload across 12 cylinders, the engine reduces the mechanical stress on individual components, allowing for much higher RPM limits. Focusing on the mechanics, this rapid firing sequence also dictates the engine's acoustic profile by creating a denser flow of exhaust gases. That density produces a high-pitched roar. The sound waves are packed so tightly together that they create an exotic scream rather than a low-frequency rumble. This sound is the audible result of the same high-frequency firing order that gives the engine its famous refinement. Despite its refinement, the V12 has flaws. These engines are large, heavy, and significantly more complex to manufacture than modern turbocharged alternatives. Their high fuel consumption makes them difficult to justify in an industry moving towards strict efficiency standards. To survive, the V12 is evolving. The Lamborghini Revuelto shows how manufacturers are adapting the architecture for a new era. Engineers are now integrating a hybrid system. By pairing the V12 with electric motors, they can use instant torque to bridge any small inefficiencies in the combustion process. This allows the engine to meet modern emission standards while keeping its high-revving mechanical character intact. The V12 remains a pinnacle of engineering because it preserves a sensory relationship between the driver and the machine, prioritizing balance and emotion in a changing world.